Hey guys, sup, Connect with Cubes here, and in this video, I will be going over all the parodies on all of the different big cubes. And obviously, some of the most basic parodies that we can go over first will be on the 4x4. So if I just scooch everything else out of the way, the case that we are greeted with here is this is called PLL parody, where we have two edges that are adjacent with each other, and they need to be switched like this, and this doesn't happen on the other two faces. And if there were PLL parody, adjacent PLL parody on both sides, that would just be a Z-perm. And the algorithm that you want to do to solve this parody is you want to take, so you have that, you want to have one of the edges facing you, and the other one facing out to the right, and you want to do this. You want to do R2, X, F prime. So that way the two edges that you have, that one, and that one, are with each other. And you want to do this algorithm. You want to bring the right wedge down twice, and then you want to turn the very top layer twice. And then you want to bring this right wedge down twice again. And this time you want to take this entire top half, these two layers of the cube, and spin them twice. And then you want to spin your inner right wedge twice, one more time. Then take this entire top half of the cube, spin the top two layers twice, and then spin the top one layer twice. And then you want to bring back the setup moves that you had by doing a Rw2. And there you go, you have just fixed that parody. And there's another version of that parody, and it doesn't require setup moves, and it's the exact same algorithm. Just set it up here. Now this is the other parody that you could get greeted with. This one's a little bit less rare, where you have that edge needs to be over here, and this edge needs to be over here, so they are swapped completely across from each other. And what you want to do is you want to hold one of the incorrect edges facing you, just one of the two, it doesn't matter, and there's no setup moves, and it's the exact same algorithm. So bring down the right wedge twice, right wedge down twice, spin the top twice, then bring down the right wedge twice again, then spin the top two layers twice. And you can pause the video in between each move if I'm going too fast. So yeah, you spin the right wedge twice, top layer twice, right wedge twice again, then the top half twice, and then to finally finish it off, spin the right wedge twice, and then do the top layer twice, and then the top half twice. And those are both versions of PLL parody. And now I'm going to show you a couple of different OLL and edge parodies. So 4x4 is done. With the PLL parody is done. And now let's move on to some of the much weirder cases. Let's just go straight to the biggest cube allowed in the WCA, the 77. And now this parody, this might look really freaky, this might look terrifying, but it's all the exact same algorithm. It's all the same algorithm, but you just do it with more than one layer. And let me show you what I'm talking about here. So just like what we did on the 4x4, we did it with one wedge. We're going to do that with two wedges, and there's a bit of a different algorithm. And so what we do to fix this is we bring down these right two wedges. We bring down the right two wedges. And this algorithm might be a little complicated, so just try and stay with me. So bring those right two wedges down, and then you want to spin the top twice. Then you want to bring the left two wedges down and spin the front twice, like that. And then you want to lift those two left edges back up and spin the front face one more time. Okay, so now we're done with the left, and we're going to move back over to the right. You want to spin the right, hang on. Spin the right two wedges twice, like that. Spin the top twice. Bring the right two wedges back up once. Then turn the top twice. And then because we brought the right wedge back up, bring the two right wedges back down and spin the top twice. Okay, so after that giant mess, we are now just about all basically done. You see that we have this ginormous line in its opposite field of color, and this opposite line in its opposite field of color. What you want to do is spin the front face twice, so those lines right there can align like with that giant blue one and the yellow one. And then spin the right two wedges twice again. And then just finish it off with the front twice. And that was probably one of the weirdest cases we'll go over. The rest of them shouldn't be too complicated. And when we get to the 6x6 and the 5x5, we'll use exactly the same algorithm. We'll just be using different layers. So, so that was pretty much the worst case you can get. It hardly ever happens, though. Now we'll move on to the 6x6 case, where we have a really small parity and just those two edges are flipped. Well, you want to do the exact same algorithm. Hold the messed up edge facing you, and you want to bring the right wedge down, then turn the top face twice, then bring your left wedge down and spin the front twice. Then you want to bring your left wedge back up and spin the front twice. And so now we're done with the left. We're done with the left for now. And now we're going to spin the right wedge twice, turn the top twice, bring the right wedge back up, like that. Bring the right wedge back up, spin the top twice, bring the right wedge back down, and spin the top twice. And so again, just like on the 7x7, we are greeted with the line that is in its opposite color, and this line that's in its opposite color. And again, just spin the front twice so those two lines in their opposite field of colors are aligned, and spin your inner right wedge twice. And then again, finish it off with a front twice. And now you have just solved that very small parity. And now, we're going to do that exact same parity, but much bigger. I'll see what I'm talking about. I'll set it up. Just setting it up right now. Don't do anything just yet. I'll just set it up. And then, okay, so here's what it looks like. It is when this entire edge is flipped incorrectly, not just little itty-bitty pieces here and there, like not just the inner ones. The entire edge is flipped incorrectly. Now, Usually when you encounter edge parity like this, you do the exact same algorithm each time. It's just that sometimes you do it with the inner wedges, and sometimes you do it with both wedges. And for this one, just like on the 7x7, you saw how we brought both wedges down. We are going to do essentially what we did on the 7x7, actually exactly the same thing as a 7x7. Bring the two right wedges down, spin the top twice, bring your left two wedges down, and spin the front twice. Then, lift up those two left wedges and spin the front twice. And then you want to spin your right two wedges twice, turn the top twice, bring your right two wedges back up, and spin the top twice. And I would highly suggest pausing in between each move so you can do it. And then bring your right two wedges back down and spin the top twice. And yet again, we have the line in its opposite field and this line in its opposite field. And we want to spin the front twice to align the lines, and then do the right two wedges twice to fix the line, and then just finish it off with a front twice. And now you have just solved pretty much every single possible edge parity case on the 6x6 and 7x7, which are the bigger cubes. And now we have this parity that occurs, I think, pretty quite often on the 5x5, is when you have the outer two edges are flipped incorrectly. And yet again, we're going to do the exact same algorithm, and I'm going to go a bit faster because this is the fourth time doing this, and you pretty much get the idea, I assume, on how to do this. So, we bring down our right wedge, just like that, spin the top twice, bring the left wedge down, and spin the front twice, then lift the left wedge back up, and spin the front twice. And you want to spin your right wedge twice, turn the top twice, bring your right wedge back up, spin the top twice, bring your left wedge back down, spin the top twice, and yet again, for the last time, you have this color and its opposite color, and this line and its opposite color. Spin the front twice to align those colors, spin your right wedge twice to fix everything, and then spin the front twice to finish off your moves. And now, by this point, if you redo those algorithms over and over and over until you absolutely know them every single time you encounter one, you should pretty much have zero issues with parity. You'll have OLL parity, edge parity, and PLL parity. And that is, I'm pretty sure, I think, every single possible parity that you can get ever. So, yeah, if you want to know any kind of parity that you've ever encountered on any big cube, just come to this video and watch it again, and you'll get it completely memorized. So, yeah, hope you found this pretty helpful, and if you did, thumbs up the video, and if you like the videos that I make, please subscribe down there. It really helps, and yeah, see you later. Bye.